All right, so these next couple of questions are asking us to divide some polynomials. One thing that this question does not do a good job of doing is actually telling you to actually write the quotient. When I give you the problem on the test, it's going to ask you to write the quotient and the remainder as well. So what are we dividing here? We are dividing negative 3x to the third minus 3x squared minus x minus 2. We are going to divide that by the quantity x plus 2. So based off of the work that you did in section 5-4, we would need to do synthetic division here. What number would go in this box right here? You got it. It would always be the opposite of that number right there. So in this case, negative 2. And then you put the coefficients here next. So negative 3, a second negative 3, and then we have a negative 1, followed by a negative 2. I think we have them all accounted for. 3, 2, 1, 0. Yeah. Then we're going to add, right? And then we bring down the first number, so there's negative 3. Next move is to multiply the negative 2 times the negative 3, which gives us a positive 6. Write that product right there, and then we add those two numbers together. Negative 3 and 6 makes a positive 3. Negative 2 times 3, that makes negative 6. Add those up, makes negative 7. Multiply those out, we get positive 14. Add those up, that puts us at a positive 12. We square that number off because that number right there is your remainder. And then these numbers that you see right here are your quotient. Now when you take a cubic polynomial and divide it by a linear polynomial, the quotient is 1 degree less. So what you're actually looking at right here is negative 3x squared plus 3x minus 7 with the remainder of 12. And so that should be your final answer, just like that. Okay? Now these two problems, is it a factor? Well, a linear factor would actually be a factor if when you do division, you end up with a remainder of 0. So we do the exact same thing that we just did above. See how that's a negative 5, so we'll put a positive 5 here. Look at those coefficients in front, so that'd be a 1, a negative 8, a 17, and a negative 10. And we add, bring down the 1 because there's nothing to add it to. Multiply 5 times 1 gives us the 5. Add those together, that gives us negative 3. Multiply, there's negative 15. And then add that up, you get a 2, and then 5 times 2 gives you 10. And then we get a remainder of 0. So here's the good news. Because we have a remainder of 0, yes, that means that this guy is a factor. And then do you notice there's a second part to this question? Let's write p of x as a product of two factors. The two factors, well, if we've just proven that this is a factor, that's one of them. Okay, so far in our answer we can say yes. And we know that one of the answers is that p of x could be the x plus the 5, x minus the 5. And then what about the second factor? The second factor comes from you looking at that quotient as being 1x squared minus 3x plus 2. That's your other factor. Okay, so that's what they want you to do. So if we look at the next one here, is x plus 2 a factor of this polynomial here? Let's find out. Opposite, so negative 2, a 1, a 5, a negative 1, and a negative 9. This would be a factor if we got a remainder of 0, right? So bring down that 1 because there's nothing to add it to. That'd be negative 2. That would add that up to a 3. That'd be a negative 6. That would be a negative 7. And then we'd have a positive 14. Negative 9 plus 14. Isn't that, let's see here, 9, 14. Wouldn't that be 5? I think that's 5, right? Right? I think so. Oh yeah, I know so. So since this is not 0, is this a factor? This is not a factor. We are good to go there. There's no factors to write this in, so we can stop just right there. Now, number 15 is a pretty interesting question. It's asking you to use not synthetic division, but synthetic substitution to find p of 4 for this function right here. I'll tell you this right now. Listen carefully. This question will be multiple choice. you're going to see 4 answers for what P of 4 would be using synthetic substitution. I will say this right now. I would not use synthetic substitution on this problem. You know what I would do? Here's exactly what I would do. You move over here for a second. I would take this guy right here, that function, x to the 4th plus 10x to the 3rd plus 2x squared minus 5x minus 6, and do this first. Why don't we just type that into the graphing calculator? Then, why don't we just go to the table of values and go straight to 4. Why 4? Because that problem is asking us, what is P of 4? So, essentially what this question is asking you to do is they're saying, put a 4 in there, 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 do that math and tell us what the answer is. We just did that right there, and we just figured out that that answer is nothing more than 902. Okay? That's it. 902. I've just figured it out. Done. P of 4 is 902. If you really want to do synthetic substitution, here's what you do. The problem why I don't advertise synthetic substitution is synthetic substitution, unlike division, see why we put the opposite number here and the opposite number there? Synthetic substitution, you actually don't put the opposite number in there. And then we'd have 1x to the 4th and 10 and to the 3rd, and then 2x squared. So a 2 is represented, the first power is represented, and the 0 power is represented. And then we'd have to go through and do all of this. I mean, which can be done. It just makes really the multiplication work pretty annoying to do. You know, there's a lot of calculations that kind of have to take place here to get this answer going just right. And so there's plenty of opportunities here to goof this up. But if you have a calculator, it's really not too bad. Let's see what that means, 908. And then what would happen here is that that last number that you would get, that remainder, is what that final answer is. Okay? But once again, I want to say, please, 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 when you see this problem, please do it that way. All right? Now, take a look at number 16, a cubic polynomial. Since it's cubic, the fundamental theorem of algebra says there must be 3 roots to that problem. So suppose they gave you 1 root, and then they gave you a second root right here. What does the 1 additional root have to be? We talked about this one. This is a question from section 5-5. So if you need some more reference, go ahead and reference that 5-5 video. And that might tell you what that answer needs to be right there. If 3 plus the square root of 6 is an answer, then 3 minus the square root of 6 must also be an answer. Okay? And so in the next segment of the video, we will wrap up the rest of this review.